Hello friends, welcome you all to my channel. In this video, I will provide the solution for the problems in limits related to LHL, left hand limit, right hand limit and existence of limit of the DPP sheet number 5. So let's get started. Okay, let's solve the problems. The first problem says, so these are the limit and we have to find the LHL, RHL and check the existence of the limit at the given point. So the first problem is uh, the given function fx is -1 to the power greatest integer function of x, gif. This is gif function, uh, and we have to check uh, the limit of fx at x tending to n, where n is a natural number. So let's find the LHL. So LHL, we have limit x tends to n minus f of fx equals limit h tends to 0 f of n minus h. This equals limit h tends to 0 minus 1 to the power box of uh, n minus h. So now uh, h is a positive quantity, very small, greater than 0. H is greater than 0. This implies uh, n minus h will lie between -1 and 0. Since h is a very small positive quantity, n minus h, sorry, uh, n minus h will be less than uh, n but greater than n minus 1. So n minus h will be less than n but greater than n minus 1, since h is a very small positive quantity. This implies box of n minus h will be n minus 1. So this equals -1 to the power n minus 1. Now let's see what is the RHL. RHL equals limit x tends to n positive fx equals limit h tends to 0 f of n plus h. This equals limit h tends to 0 minus 1 to the power box of n plus h. Now h is a very small positive number quantity greater than 0. This implies n plus h will be greater than n but less than n plus 1. So we will have box of n plus h equals n. So this equals -1 to the power n, and clearly we see that LHL is not equal to RHL. Therefore LHL not equals to RHL, which implies limit x tends to Fn, the given limit does not exist. Okay, let's see the next problem. The next problem says it's the function given is uh, box x minus 3 plus mod of x minus 4 and we are to check the limit at x tending to 3. So let's see what is LHL. LHL is limit x tending to 3 minus fx. This equals limit h tending to 0 f of 3 minus h. This equals limit h tending to 0 uh, 3 minus h minus 3 plus mod of 3 minus h minus 4 this thing. This equals limit h tends to 0 box of minus h plus mod of minus 1 minus h. Now, since h greater than 0, a very small positive quantity implies that minus h will be greater than minus 1 and less than 0. This implies that box of minus h will be minus 1. So this becomes uh, 0 minus h minus 1. Yeah, this becomes minus 1 and plus inside mod we have a minus of 1 plus h. So if we take it out from the mod, it will become 1 plus h. So 1 plus h equals h. So LHL is coming out to be uh, h. LHL is coming out to be h. Let's see what is RHL. RHL equals limit x tends to 3 positive 3 plus fx equals limit h tends to 0 f of 3 plus h. This equals limit h tends to 0 x minus 3. So mod of x minus 4. This is limit h tends to 0 box h plus mod of h minus 1. h minus 1 minus 1 minus 1. Okay. Mm, Now h tending to 0 implies h is greater than 0 but less than 1. This implies box of h equals to 0 and h minus 1 will be less than mm, so h minus 1, what will be mod of h minus 1? When h tending to 0, uh, okay, uh, h tending to 0 implies h tending to 0 implies h minus 1 tending to minus 1 implies mod of h minus 1 tending to 1. So this becomes 0 plus 1 equals 1. And over here I think I did a mistake. Over here when we have a mod of minus 1 minus h, when we put h as 0, this will become mod of minus 1, which is 1. So here is a mistake we did. This will be 1 and we get uh, the result as 0. So LHL is 0 and RHL is coming 1. Therefore, LHL not equals to RHL implies limit x tends to 3 fx does not exist. Okay, let's see the next problem. The next problem is the function fx given is e to the power box x plus mod x minus 2 divided by box x plus mod x. We have to check the limit existence. We have to find the LHN and RHL of this function uh, it at x equals to 0. So LHL left hand limit is limit x tends to 0 minus fx, which equals limit h tends to 0 f of 0 minus h. This equals limit tends to 0 e to the power box 0 minus h zero minus h plus mod of 0 minus h minus 2 box 0 minus h plus mod 0 minus h. This equals limit h tending to 0 e to the power box minus h mod of minus h is h minus 2 divided by box of minus h and plus h. Now h is tending to 0 implies minus h will be less than 0 and greater than minus 1. This implies box of minus h equals to minus 1. So this becomes e to the power minus 1 plus 0 minus 2 uh, minus 1 plus 0. So this is uh, 2 minus e to the power minus 1. Okay, let's see the RHL. The right hand limit is x tending to 0 plus fx equals limit h tending to 0 f of 0 plus h. This equals limit of h into 0 e to the power box 0 plus h plus mod 0 plus h minus 2 divided by box 0 plus h plus mod of 0 plus h. This equals limit h tend to 0 e to the power box of h plus mod of h uh, is h minus 2 divided by this is box of uh, h plus h. Now h is tending to 0 implies h is greater than 0 but less than 1. This implies box of h equals to 0. So the limit becomes e to the power 0 plus h minus 2 0 mm, 0 0 mm, this equals limit h tending to 0 mod of e to the power h minus 2 and divided by h. Let's see if we use the expansion series formula of e to the power h, which is 1 plus h plus h squared by 2 factorial by h cubed by 3 factorial, so on, we get limit h tending to 0 1 plus h plus h square 2 factorial by cubed by 3 factorial, so on, minus 2 by h. This equals limit h tends to 0. 1 minus 2 becomes minus 1 plus h plus h square by 2 factorial plus h cube by 3 factorial and so on divided by h. Now if you divide the numerator by the h, this becomes limit tending to 0 minus 1 by h plus 1 plus h by 2 factorial plus h square by 3 factorial and so on. If we substitute h as 0, this becomes minus infinity plus 1 plus 0 is equals minus infinity. Since h is tending to 0, this implies 1 by h tending to infinity. This implies minus 1 by h tending to minus infinity. So clearly we see that LHL is not equals to RHL, because LHL we got 2 minus e to the power minus 1. For LHL not equals to RHL, this implies limit x tending to 0 fx does not exist. Okay, let's see the next problem. Next problem, fx is 5 by root 2 minus root x, and we are investigate the limit of this function at 2. So LHL is limit x tends to 2 minus fx. This equals limit h tends to 0 f of 2 minus h. This becomes limit h tends to 0 5 by root 2 minus root of 2 minus h. Okay. Let's rationalize the denominator and we get root 2 plus root 2 minus h divided by root 2 minus h. Okay. This becomes limit h tends to 0 5 root 2 plus 2 minus h divided by the denominator becomes, if we apply the formula a square minus b square equals to a minus b into a plus b, it becomes 2 minus 2 minus h. This is limit h tends to 0 5 root 2 plus 2 minus h divided by h. Okay. This equals, if we take the 5 out, this becomes root 2 by h plus root over 2 minus h divided by h. If we take the h inside the root, it becomes 2 by h square minus 1 by h. Now, when h tends to 0, this implies 2 by h square tending to infinity. Hmm. This implies minus 1 by h tending to h square 1 h square 1 minus 1 by h tends to minus infinity. So it becomes 5 into also root 2 by h tending to infinity. So this becomes infinity plus root over infinity minus infinity. This is infinity. Okay, now let's see the LHL we got infinity. What is RHL? RHL equals limit x tending to 2 plus fx equals to limit h tending to 0 f2 plus h. This becomes limit h tends to 0 uh, 5 by root over 2 minus root over 2 plus h. Similar as like the HLL, we rationalize the denominator and we get 5 root 2 plus 2 plus h divided by 2 minus plus. This becomes limit h tends to 0 5 root 2 plus 2 plus h divided by 2 minus 2 plus h. This equals, take the 5 out, root 2 plus 2 plus h minus h. We get minus h. This is root over limit h tends to 0 minus root by h minus root over let's bring the minus outside, so minus 5, and we get plus 2 by h square plus 1 by h. Now this becomes as h tends to 0 implies 1 by h tending to infinity implies 1 by h square is also tending to infinity. So this becomes minus 5 infinity plus root over infinity plus infinity. This is minus 5 infinity, this is minus infinity. So the LHL is infinity and the RHL is minus infinity. So they are unequal. Therefore, LHL not equals to RHL. So limit does not exist. Limit does not exist. Does not exist. Okay. So let's see the next problem. Problem number 5. If x is uh, mm, mod x cube of mod x divided by a minus box x by a whole cube, where a is greater than 0. We have to check the limit of fx at x equals to a. Let's see what is LHL. LHL is limit x tending to a minus f of x. This equals limit h tending to 0 f of a minus h. This equals limit h tending to 0 uh, a minus h cube divided by a minus box a minus h by a whole cube. This equals limit h tending to 0. Now a minus h uh, a minus h, a is tending to 0, h tending to 0 implies a minus h tending to a. So here we have, and mod of a cube is, so we have here a cube divided by a. Since a is greater than 0, obviously mod of a will be a. It's given that a is greater than 0. So mod of a is a. A greater than 0, this implies mod of a equals a. So it becomes a cube by a minus, we have 1 minus h by a whole cube. Now this is box 1 minus h by a. Now uh, h is tending to 0 implies h by a is also tending to 0. This implies, and since a and h are both positive, h and a are both positive, so we will have h by a greater than 0 but less than 1. Greater than 0, less than 1. Okay. This implies 1 minus h by a. This implies if we multiply this inequality by minus 1, we get the inequality, the inequality sign gets reversed and we get minus 1. We get this. This implies if we add 1 to it, to this inequality, it becomes it becomes 1 minus h by a is greater than 0 and less than 1. This implies box of 1 minus h by a is 0. So this becomes hmm, is it right? A 1 minus h by a. H by a, h tending to 0 means h by a is tending to 0, greater than 0, less than 1, okay. Minus h by a is uh, less than 0, greater than minus 1, okay. If I then add 1 to it, it becomes 1 minus h by a greater than 0 and less than 1. So box of this is 0, okay. So this becomes a cube by a, which is a square, and this becomes 0. So this is a square. LHL is a square. Now let's find RHL. RHL is limit x tends to a positive fx. This equals limit h tends to 0 a plus h. This equals limit of h tends to 0. Okay. X cube by a plus h cube by a minus box of x by a plus h by a cube. This becomes limit h tends to 0 h tending to 0, h when tending to 0 implies a plus h also tends to 0. This implies mod of a cube tending to a cube. So this is a cube by a minus, over here we have 1 plus h by a cube. Now h h tending to 0 implies h by a tending to 0. This implies 1 plus h by a will be greater than will be just little greater than 1. This implies 1 plus h by a, but it will be less than 2. So this implies box means the greatest integer function is equals to 1. So this becomes a square minus 1. RHL is a square minus 1 and LHL is a square. So they are different. Therefore, LHL not equals to RHL implies x tending to a fx does not exist. Okay, so let's see the next problem. Problem number 6. The fx is given as 3x plus mod of x 7x minus 5 into mod of x, and we have to check the limit at 0. Let's see what is the LHL. Uh, Limit x tends to 0 minus fx equals limit h tends to 0 f of 0 minus h. This is limit h tending to 0, 3 0 minus h plus 0 minus h mod of divided by 5 into 0 minus h minus 5 mod. This becomes h tending to 0 minus 3h plus mod of h is greater than 0, mod of minus h is greater than 0. This implies minus h less than 0. This implies equals h. Therefore, plus h, in the denominator we have minus 7h and minus 5h. This equals limit h tending to 0 minus 2h minus 12h equals 1 by 6. Let's see what is RHL. RHL equals tending to 0 positive. This is limit h tend to 0 f of 0 plus h. This is limit h tending to 0, 3 0 plus h plus mod of 0 plus h divided by 5 0 plus h minus this. This becomes limit h tends to 0, 3h plus h divided by 7h minus 5h. This is limit h tending to 0, 4h by 2h equals 2. Since LHL and RHL is different, therefore LHL not equals to RHL implies limit x tending to 0 fx does not exist. Okay, let's do the next problem. 7. The given function is it's a piecewise definition 1 plus x square when x lies between 0 and 1, and it is 2 minus x when x greater than 1. We have to check the limit of fx at 1. So let's find out the LHL. It's limit x 1 minus fx equals limit h tending to 0 f of 1 minus h. This becomes limit h tends to 0. Now 1 minus h, h is a positive quantity, h is 0, h greater than 0, so definitely 1 by h will be less than 1. So we have to use the first definition, that is 1 plus x square. H tends to 0. This is 1 minus h square. This becomes 0, 2 minus 2h plus h square. Hmm. 2 minus 2h plus h square. This equals 2. Now let's see what is RHL. RHL is limit x tends to 1 plus fx equals limit h tending to 0 f of 1 plus h. This equals limit. Now 1 plus h over here implies 1 minus h is less than 1. Now here h greater than 0 implies 1 plus h is greater than 1. So when x is greater than 1, we will have to use the second definition of fx, that is 2 minus x. 2 minus x. So this becomes 2 minus 1 plus x. This is 1 minus h. This is 1. So clearly LHL is different from RHL. Hmm. Uh, Therefore, LHL not equals to RHL. This implies limit x tending to 1 if x does not exist. Does not exist. Okay. Let's see the next problem. Problem number 8. The fx given is x by a box b by x, and we need to check the limit at x equals to 0 of fx. Here box is the greatest integer function. So let's find LHL. LHL equals limit x tending to a minus fx. This equals limit h tending to 0 f of a minus h. This is limit h tending to 0 we have a minus h by a box b by a minus a minus h. Hmm. Hmm. Box b by a minus h is less than a. F of a minus x tends to a. We have to find, oh, limit at x tending to 0. Okay, so this will be 0. Sorry, this will be 0 and this is 0. this is 0, this is 0. So this becomes limit h tends to 0. Mm, mm, ah, 0 minus h. Mm, mm, 0 minus h by mm, box box minus h by mm, uh, this is minus h by a. We can substitute the box with this is b by 0 minus h means it is b by minus h minus fractional part of b by minus x. So we have used the identity or the formula that x uh, we know that box x equals x minus fractional part of x. We know this formula. So we have applied that. In this case, in our case, the x is b by minus h. So if we remove the box, we get b by minus h minus fractional part of b by minus h. Now, if I bring the minus h by a inside, we get b by a plus h by a into fractional part of b by minus h. Now we know that fractional part of any real number always lies between 0 and 1. It is uh, greater than equal to 0 and less than 1. So also h tending to 0, this implies h of fractional part of b by minus b h is tending to 0. So this becomes b by a plus 0 equals b by a. So the LHL is b by a. Now let's see what is RHL. Uh, RHL is limit x tending to 0 positive fx is equals limit h tends to 0 f of 0 plus h. This equals limit h tending to 0, 0 plus h by a box b by 0 plus h. This equals limit of h tending to 0, h by a. We again substitute the box with b by h minus the fractional part of v by h. And if we bring the h by a inside, we get as b by a minus h by a. So h uh, we have h is tending to 0 and the fractional part of b by h is less greater than equals to 0 and less than 1, this implies h by a into fractional part of b by h is tending to 0. This equals b by a minus 0 equals b by a. So RHL is b by a and LHL is b by a. They are same. Therefore, LHL equals RHL. This implies limit x tending to 0 fx exists and limit x tending to 0 fx is equals b by a. Okay. Let's see the next problem. Problem number 9. The fx given is 2 to the power minus 2 again to the power 1 by 1 minus x, and we are to check the limit of this function at x equals to 1. So LHL is limit x tending to 1 minus fx equals to limit h tending to 0 f of 1 minus h. This equals limit h tending to 0 2 to the power minus 2 to the power 1 minus h. This becomes limit h tending to 0 2 to the power minus 2 1 by 1 plus by h. 1 minus x, so 1 minus h, 1 gets cancelled plus h. Okay. Now we know that h tending to 0, this implies 1 by h is tending to infinity. This implies 2 to the power 1 by h is also tending to uh, infinity, and this implies 2 to the power this implies minus of 2 to the power 1 by h is tending to minus infinity. So here the limit becomes 2 to the power minus infinity. This is 1 by 2 to the power infinity. This is 0. So the LHL is becoming 0. Let's see the RHL. RHL is limit x tending to 1 plus fx equals limit h tending to 0 f of 1 plus h. This becomes limit h tending to 0 2 to the power minus 2 1 by 1 minus 1 plus h. This becomes h tending to 0 2 to the power minus 2 to the power minus h. Okay. So h tending to 0 implies 1 minus 1 by h tending to minus infinity. This implies 2 to the power minus 1 by h tending to 2 to the power minus infinity tending to 0. This implies minus 2 to the power minus 1 by h is also tending to um, 0. So this is equals 2 to the power 0 equals 1. So RHL is 1 and LHL is 0. So they are different. Therefore, LHL not equals to RHL implies limit x tends to 1 if x does not exist. Okay, let's see the last problem. Problem number 10. If x is x minus 2 divided by x minus 3, and we have to check the limit of fx at 3. So LHL is limit x tending to 3 minus fx equals limit h tending to 0 f of 3 minus h. This equals limit h tending to 0, 3 minus h minus 2, 3 minus h minus 3. This equals limit h tending to 0, 1 minus h minus h. Hmm. Mm. So if we divide by h both numerator and denominator, we get h minus 1 by minus 1. By h minus 1 divided by minus 1. So h is tending to 0 implies 1 by h is tending to infinity. This is infinity minus 1 minus 1. This is minus infinity. Hmm. Okay, let's see the RHL. RHL equals limit x tending 3 plus fx equals limit h tending to 0, 3 plus h. This equals limit h tending to 0, 3 plus h minus 2 divided by 3 plus h minus 3. This becomes limit h tending to 0, 1 plus h divided by h. So if we divide numerator and denominator by h, we get 1 by h plus 1 by 1. and when h tending to 0 implies 1 by h tending to infinity. This becomes infinity plus 1 by cos infinity. RHL is infinity and LHL is minus infinity. So they are not same. Therefore, LHL not equals to RHL implies limit x tending to 3 fx does not exist. Okay, that was all the solution of the DPP sheet number 5. If you like this video, then please support me by subscribing to my channel and like this video and share my channel and videos with your friends. And I will try to make more DPPs based on the problems and limits of all the topics that I have already discussed. And in the next upcoming videos, I will address the indeterminate form in 0 by 0 and infinity by infinity. Then I will move on uh, of how to find limits by rationalization method, factorization method, and how to find limits of trigonometric functions, and how to find limits using the expansion series. So those videos will come uh, very soon. Thanks for watching, and until the next video, take care and bye.